Hello, and thank you for joining us today for the Observability Trends webinar series. I'm Grant Swanson, and today we have Sush, Product Manager at Observe, who will be leading you through a short presentation and demo. Welcome, Sush.
Hey everyone, really excited to be talking to you all about Observe and some of our newer features. So thank you for joining. I'm going to go ahead and start off with just sort of a few slides introducing this topic, and then I'll jump into a live demo of the Observe product. So the topic of today's webinar is busting silos, effective log analytics with correlation tags. I think it's helpful to sort of step back for a minute and just talk about, how software is built nowadays. Back in the old days, software was built sort of on static infrastructure with lower data volumes, a lower number of changes per month or year. Whereas nowadays, we have generally most software is built on the cloud. A lot of software is built on a microservice architecture, and there's a higher rate of changes per year through continuous integration and deployment. And what this results in is a lot more changes to track and a lot more data. We know that modern software generates massive amounts of telemetry. Cloud native apps and dynamic infrastructure are only increasing this trend. And a challenge we hear from a lot of teams is that, well, the telemetry data we need to be able to observe is actually is more fractured than ever. It's fractured across different data sources, different teams. And this is one of the problems that kind of Observe was sort of originally founded to tackle. We also know that troubleshooting complex issues requires connecting the dots. It really involves looking across telemetry sources, layers of the stack. This could be data types like logs, metrics, and traces, but also sources. Telemetry that's coming from application logs, traces if you have tracing implemented, infrastructure metrics, which could be hosts or Kubernetes, and even customer data, which maybe none of the above, but just static information that's stored about your customers. And the Observe architecture is sort of designed to be able to handle this. So on the left-hand side, you see our collection layer, where we ingest data from cloud environments, container orchestration systems, pretty much any source of data can be sent to Observe. And we focus on being open telemetry native. We ingest all of that into our data lake. And on top of that, we have a schema on demand layer and a data correlation layer, which I'll talk a little bit more about today, that then can let you flexibly run queries, create monitors, set up dashboards, etc. So let's talk about the Observe log analytics capability. Observe offers an expressive query builder for querying your logs, log search with up to 13 months retention, schema on demand, so you can flexibly query your logs regardless of what schema they're being sent in, and on-demand visualizations that help you sort of understand trends in your logs without needing to necessarily always create a metric off your logs. Though we also offer the ability for improved performance to be able to create metrics off of logs. And one of our newer features is the log correlation ability. What this enables you to do is to query multiple log sources that have shared common attributes such as IDs, usernames, etc. In other systems, this is known as log subqueries. And whenever two or more observed data sets share a link to a resource or a correlation tag, you'll be able to use this correlation ability in the log explorer to run queries across these data sets. Correlation tags is one of our newest features that will enable you to more easily connect data within Observe. So correlation tags are metadata that can be flexibly added on top of any observed data set, regardless of the underlying schema. Now, if you're using our Observe agent, Observe will automatically tag data that's coming in order to make sure that it's connected to all of the other telemetry in your system. But in the scenario where, let's say, you have some custom data that you want to start sending to Observe, correlation tags can be applied to that very easily through the UI, which I'll show you in a second. And because it's a flexible system that's independent of the schema, you don't need to worry about, let's say, two teams aligning on a certain data format. So let's just look at how that works, right? I might have on the left-hand side a log format coming from team A. They are including a message as well as a user capital ID attribute. And on the right side, there's a log format from team B. They also have a message, but they have the user ID is formatted differently. It's formatted at user.id. This would be a challenge in a lot of systems. A lot of legacy vendors are not able to handle this sort of divergence of the schema here because these two attributes are actually, they mean semantically the same thing, but they're named differently. But with observed correlation tags, you can apply a user.id correlation tag to these two logs, and then observe will let you query across them pretty seamlessly. So I'm going to just jump into a quick demo just so you can see how this actually works in the product. I'm sure a lot of you are curious, well, you know, can I see an example of this? Well, we'll jump into that now. So just pull up the right screen here. All right. So I'm here within my instance of Observe. Now, in this situation, I'm running an e-commerce app. I have an e-commerce app where users come, they check out different items like chairs, bottles, mattresses, desks, etc. And I just got a support ticket that a lot of users are failing to be able to check out their items. That's really unusual. And as the on-call engineer, I'd like to look into a little bit further what's going on here. So what you'll see is I have these logs for my checkout service that include a message about what's happening. They also have this information about the user ID right here, user_ID. Unfortunately, though, this doesn't include any other information about the user, like their name, their geo, etc. That information is stored within our log, within the logs for our login service. So it's emitted by our login service. This has the username, as you can see here, you know, Mark Zuckerberg, Sundar Pichai, etc., and also the user ID. But if you notice here, the format of this user ID is actually different. It's user and then capital ID, whereas the checkout service logs are formatted as user_ID. Now, in theory, it would be great for the different teams at my company to kind of align on how they're logging user IDs. And that would be ideal, but in practice, sometimes this doesn't happen. Now, how do I tackle this problem? This is pretty thorny. I know that I have checkout service logs here. I know that I also have more information in the login service about which users are logging in, and I want to be able to run a few queries about you know, which users are logging in that are getting failed checkouts. Now, normally this query would be pretty straightforward if the user IDs were kind of normalized, but in this case, they're not. So how do I do this? Well, I might first go and say which checkouts are actually failing. Let's just see that information. Okay, well, I can see there's, you know, within the last, you know, 30 minutes or so, there's a lot of failed checkouts for the bottle, for the vase, etc. And I can see they're all coming from, you know, it looks like from one user ID, but I'm not able to get more information on this because the login service actually has that enriched data. So here's where I can use correlation tags to help speed up my investigation and help me kind of flexibly run a query without having to copy and paste data across different logs. So I'm going to go to the datasets tab here. I'll find the datasets that I want to basically link together. In this case, I mentioned already that there's a login service and checkout service. Both are sending logs to observe. At the top here, there's a correlations button here that I'll click. And I'll click Add Correlation Tag. Now here, the data that I was referencing earlier for the user ID is actually nested. It's within some semi-structured JSON, but that's not an issue. I can still tag it. And I can apply sort of a tag format here, which is user ID. I'll use this sort of standard format, and I'll save that tag here. And then I'll go and I'll do the same for the login service. differently formatted, but I'll apply the same correlation tag. All right, so both of these observed data sets have this correlation tag now. Now let's see what this enables me to do. If I go back to this, checkout data that I started with, I'll see that this user ID attribute has been tagged with kind of the canonical user ID. And that lets me do a few things. One is if I just look at one of these rows of the checkout service, I can actually go and I can see the related logins for that user ID. And what that's basically doing is it's running, again, a query for this specific checkout. What are all of the logins that happened for this user ID in that checkout? And I can see, well, this is these are all the users that are logging in, logging out. Now, what I want to do is specifically, I want to see for the failed. What I want to see is specifically for the failed checkouts, which user is experiencing that, or which set of users. So I'll run a query here, get all of the failed checkouts, and now I'm going to use the add correlation ability here. I'm going to use the add correlation ability to find all of the users that experience a failed checkout and return all the logins for those users. What I'm seeing here is basically all of the logins for the users that had a failed checkout. And what's initially kind of stands out as suspicious is, well, this is all one user, and there's a lot of logins and logouts. That seems pretty odd. Now I can visualize this data as I was mentioning earlier. And if I visualize it, I can see there's some pretty big spikes here. 20 logins, 30 logins. Basically, this is sort of suspicious behavior. Seeing a user log in this many times is very unusual. I can even change the resolution on this if I want to see how many logins are happening, let's say within a 5-minute interval. I can change the resolution on that chart. Well, it looks like it's about 50 logins within 5 minutes. This is definitely unusual. At this point, I could say, I found something that doesn't seem right. I'm going to flag this, hand it off further to my security team to look into. It's possible this user is kind of bombarding our page, and that's causing these failed checkouts. Now, I also want to show you how you can link your log data to other data that's automatically tagged and observed using correlation tags. Here, again, going back to the checkout service, you could see that I do have this service name being logged. However, it doesn't seem, because this is custom logs, doesn't seem like this is connected yet to the other data I have in my system. So I've already instrumented this service with tracing. Now, for the specific investigation we just kind of walked through, traces would not have been super helpful. However, it's possible that I need to see trace data to see, is there any change in sort of, request latency? Is there some bottleneck that's happening in my services? Whereas, right now, because I've sent data to observe through our agent, I already have all this data for the checkout service. Now, how can I connect these two? Right now, I'm actually not able to jump from these custom logs to the observe traces. If I go to the checkout service, you'll see that I can go straight here, go to the service, and then add the standard tag that observe has already tagged my traces with. This just takes 1 second in this case. And you'll see that it's automatically the observe UI has already populated a link for service, and I'm able to pivot from that line in the checkout service to related metrics, related traces, etc. If I do go ahead and jump to related traces, you'll see I'm now seeing all of the related traces for this checkout service. Now, when you do send data to observe through our agent, again, we automatically apply correlation tags to all your data. So this isn't something that you generally have to worry about, especially if you're sending, OpenTelemetry data to observe. or any other standard format we support. But in the case that you do have some custom log data, which we see often, custom application logs, correlation tags allow you to really easily connect, your telemetry from some of these more bespoke sources to your existing logs, metrics, traces. And as I showed you here, it really just takes a few clicks to be able to do that. All right, so I'll stop sharing here and just pause to see if anyone has any questions. If there's anything else I can kind of expound upon a little bit.
Yeah, hey Sush, we got some questions coming in here. It looks like we've got quite a few customers on the session as well. And so actually the first is, can correlation tags be added to non-event log type data sets?
Yes. Yes, the answer is yes. Yeah, correlation tags, thank you for the question, can be applied to any type of data and observe. The use case here that I demonstrated was just sort of using logs, but if you have, the metric data, trace data, basically any data that observe supports, you can apply correlation tags to it.
Excellent. We've got two more questions that just came in. Feel free to type your questions in the question window. This one is, can anyone in my observe instance add correlation tags? I'm a bit concerned about people adding conflicting correlation tags to the same data.
Yeah, that's a great question. Definitely something we're mindful of. So right now, only admins in Observe can apply correlation tags. Part of the reason is we do want to ensure that, basically folks in the count that you're trusting as admins have this ability. But we're considering in the roadmap down the road, kind of creating more granular permissions where admins can, allow subsets of users to tag subsets of data. That's a little further in our roadmap. If anyone's interested in that, let me know. But again, right now it's only admins that can apply tags to their data sets.
Excellent. The next question that just came in, does adding correlation tags have any impact on query costs?
No, there's no impact on query costs, and no impact to really any transform or query costs. Basically, correlation tags are just a metadata layer on top of your data that indicate to observe that this data can be sort of used in queries for to create kind of a common picture for you. So there's no impact to query costs or transform costs.
Excellent. We'll give it just another minute or so here. And meanwhile, I posted a free trial link into the chat window. Our free trial is fully functional and is a 2-week free trial. We have an astronomy shop there that's basically demo data that anybody can use, or you're welcome to ingest your own data and use the product. Like I said, it's fully featured. And then I don't see any other questions coming in. The other thing I added to the chat was our upcoming events. We will be at both KubeCon and AWS reInvent this year. So if you're at either one of those shows, we'd love to have you stop by the booth. Yeah, and it doesn't look like we have any other questions coming in. So Sush, thank you so much. I appreciate the presentation and demo. Everyone on the call today will get a recording of the webinar. And thank you for joining this session. We appreciate your attendance. Thank you so much.
Thank you, everyone.
Yep.